All right, welcome to Unit 5. Unit 5 is by far our most important unit for grade 9. It will set you up for the most success in grade 10. So because of that, we are going to take it slow, make sure we have lots of check-ins to make sure we're understanding it. And we're going to spend at least 3 weeks doing Unit 5, all because it's so valuable for next year. And really, the heart of this course is all in Unit 5. What you've been doing in Unit 3 and 4 is setting yourself up for Unit 5. And so we're going to start today. Hopefully, you've already done this Desmos activity, and we're going back to our favorite CHSS Fair question. The reason I keep coming back to this question is because it really sets us up for everything we're doing. And so hopefully you've done this Desmos activity and got to play around for a bit. If not, please go back and do that before you watch the rest of the video. But moving on, here we are. So we've been talking about equations of lines with tables and graphs and everything like that, but we're going to formalize it today and give it a name. It's called the slope y-intercept form of an equation. All linear relations can be represented by the equation in the form y equals mx plus b. And we've been hinting at this all last unit. We know about the slope is the number that goes in front of the x, and the flat rate or the starting value is your number that comes after. Now we're just giving it a name. Okay, so it's called the slope y-intercept form, y equals mx plus b. So very, very valuable. Of course, the m is the slope. We've been referring to it as first difference or rate of change all for a couple of units, and then we introduced the idea of slope last unit, and we're now formalizing it, calling it m is the slope and where it belongs in the equation. And then b is the letter that we use for the y-intercept. Okay, we've been talking about it as the flat rate or the initial value or where it hit where x is equal to 0. And so this slope y-intercept form of an equation is y equals mx plus b. So you got comfortable with it in the first Desmos activity. You'll be practicing some more with another Desmos activity in a second, but let's just quickly go through how we can get these. So here are a bunch of examples with determine the slope and the y-intercept of the line. So here we go, y equals 3x plus 5. So it's in the form y equals mx plus b. The coefficient, the number in front of x, is the slope. And so in this case, we're going to find the slope and the y-intercept for each of these, so the m and the b. But in this case, the coefficient, the number in front of the x, is 3. That means the slope is 3. Okay, we don't say the slope is 3x. We say the slope is 3. 3 is the number that describes the steepness of this line. Okay, and it's the rate of change. It means it goes up for 3, up by 3, up by 3. Maybe it's $3 an hour. Okay, so every hour you travel, you get $3. Okay, so this is the slope. And then the y-intercept is where this relationship begins. In this case, it begins in 5. So this could be just like the fare, where it costs $5 to get in. The initial value, the flat rate, the b is 5, and it's $3 per ride. Every ride you go on, you increase by 3. Okay, so m equals 3 and b equals 5. And then regardless if the equations change, we get fractions or decimals or negatives or positives, still the number in front of the x is still the slope. In this case, it's negative 1/2, so that means you're going down, but you began at 3, and so the b equals 3. For y equals x minus 10, it doesn't look like there's a number in front of the x, but remember there is. It's the number 1. And so the slope in this case is 1. It could be $1 for every hour or something like that. Okay, and then the y-intercept for this, you see it's y equals mx plus b. So if you see a minus b, then that must mean that the minus is the y-intercept. So the y-intercept must be a negative 10. Okay, so even though it's y equals mx plus b, if you see a negative, a minus 10, that must mean we start at negative 10. Okay, so maybe you owe somebody $10, so you're starting at negative 10, and you're earning it back by gaining $1 every time you do something. Okay, now let's write the equation line if I give you the slope and the y-intercept. So here we're going backwards. I give you the m equals 2 and the b equals 6. So it goes y equals mx plus b. So the 2's in front of the x, and the b is afterwards. So the equation is 2x plus 6. $6 to get in the fare, $2 per ride. Okay, we're very used to this. M is 1, b is 7. So this is y equals 1x plus 7. Of course, you don't necessarily have to write the 1x just like we had it up here. You could write it as just x plus 7. Both of them mean the same thing. And then regardless, even if we get an equation like this where it looks a little bit more complicated and you've got a negative 3/4 and a negative 7, still it's in y equals mx plus b form. So the negative 3/4 goes in front of the x, and this negative 7 comes at the end. Okay? One thing I want to note, since your b is negative, oh, and don't get fooled here just because I've written it backwards, okay? The slope is still here, and the y-intercept is still here. So don't, because this b is negative, what I don't want to see is this. I don't want to see you say y equals mx plus b, and then you go plus minus 7. Okay, it's not good to have a plus minus next to each other. All right, you should only have one operation at a time. And plus minus is actually like subtracting, right? Remember, if you're adding cold, you're actually subtracting, you're getting colder. So we'd rather you write it like this, minus 7. If you really want to write both signs, you could say plus and then put in brackets minus 7. That's allowed, but not one without it. But really, if you're going to do this, it makes more sense to just go up and write that. Okay, so this equation is y equals negative 3 over 4x minus 7. Now, I could give you the equation, or I could give you the information like the slope and the y-intercept like I did here, or you can get that information from a graph. So here's a graph of a green line, and we can read off the graph all the important information we need. So for example, the where it starts is not down here. The where it starts, when I'm talking about that, is your flat rate when x is 0. So you're talking about the y-intercept. And that's why it's called the y-intercept, because it's where this green line intersects with the y-axis, the y-intercept it's called. Okay, so that one is at 1. Okay, so the b is 1. Now you can choose any 2 points on the line and do our slope triangle. Remember, slope is rise over run. So why don't we start from this spot and go up a certain amount and over a certain amount. Now we can go all the way up to here and over, or we can go here and over, or we can go up. What you have to do is try and find a spot on this line that's easy to read. So for example, I don't think I'm going to go up 3 and over whatever, because it's going to be hard to figure out how far you went over. It's much better to go to a point like this one, where it's right on the line, or this one, or this one. I think it's a bit of waste of our time if we're going to go 1, 2, 3, 4, 5, 6, and then over 1, 2, 3. Why don't we pick something closer, like this point right here? And so I'm going to draw this slope triangle and go to this point. And then I can just count my rise and run. I'm rising 2 units and running 1 unit. Where's my 1? There we go. Rise 1, run 2. And so the slope is 2 over 1. Rise of 2, run of 1. And of course, 2 over 1 is the fraction that represented by m equals 2. And so from the graph, I was able to figure out the slope is 2 and the y-intercept is 1. So the equation of this line is in y equals mx plus b form, y equals 2x plus 1. Let's look at another example. The first thing you should notice about this blue line is it's a negative correlation. As you read from left to right, it's going down. But we can still determine the equation using the y-intercept and the slope. So let's find the y-intercept. It looks like it's right here. And so it looks like it's down 2. So I'm going to go off and figure out that the y-intercept is negative 2. Now, from here, I can go off and get all sorts of slope triangles. I wouldn't suggest going backwards, okay? So it doesn't make sense to be going backwards and up. Okay, we read these left to right, so I would suggest you go down and over. And again, you want to pick a spot that's easy to read, so going down 1 and over is hard to tell how far you go over, but it does look like you can go down 2 and over 3, so I think that triangle right there would be the best one to use. Of course, this is going down, so that we say our rise is negative 2, and then our run is 3. And so, if we have a slope of down 2 over 3, then our rise over run is negative 2 over 3. Remember, as I suggested last unit, we don't need to change that as a decimal. It actually makes more sense to leave it as a fraction. And I've been stressing this all year. we're okay with fractions. It means more to us to see down 2 over 3 than it does the decimal. The decimal in this is negative 0.667. And for one, it's not as accurate as negative 2 over 3 because 66666 goes on forever. But also, seeing a change in negative 0.6667, it's hard to visualize. But seeing a change as negative 2 over 3, that I can visualize as down 2 over 3. All right, so I've got my slope and I've got my y-intercept. So I should be able to come up with the equation of this line as y equals negative 2 over 3x minus 2. Okay, so now you'll be able to practice this in a Desmos activity that I have lined up for you. This is one that I made up. Actually, I've made up all the ones you're going to do this unit. So you're going to go and try this Desmos activity. So you're going to go back to Desmos and do this, and it's going to be a great summary of what we just reviewed in this video. If you would like, and you'd like more practice, you can go to page 304 and try numbers 1 to 3, 6, or 7. Some of the questions say to graph these or sketch them. You don't need to sketch them unless you want to. It's mostly just practicing with the equation of the line, y equals mx plus b. But this Desmos activity explores that as well, so you'll be doing lots of good practice in the Desmos activity. So it's totally up to you if you want to do the textbook work as well. All right, so this is a very important day. It gets us on a good start for Unit 5, and we've stressed how important Unit 5 is. So I'd like you to put some effort into this Desmos activity. Is going to be a great spot for you to get a good foundation for this unit. So best of luck.